Hello friends, today we are starting with a new topic called version control system. From the word it suggests something which is like versioning your system and controlling about. What is version control system all about? That is important to be understood. Version control system is nothing but managing your code base. It is main focus of managing a code base in a very big company. For example, a team has around 50 developers or say 50 developers including testers, business analysts and many more. All have their own code base and they are working on a simple project. A project has a code base with it and they will definitely make changes with the n number of files. So these n number of files changes and recording them like who had made the changes and avoiding the conflicts is all about understanding the version control system. That is all this tutorial about. So introduction starting with it, like I would say that version control systems are a category of a software tools that help a software team manage their source code over time. For example, say in day one we have developers XYZ. They will have their code base XYZ in their local machines, they can work on it and they will deposit a code base in a particular main repository, and later the code base will be used for the live server manipulations. In depth, we'll understand it. Let's focus on the introduction for now. It is a software. This version control system is actually a software which keeps track of every modification to the code in a special kind of database. If a mistake is made, developers can track the particular mistake, turn back the clock and compare the earlier versions of the code to help it fix it. So it allows developers to work simultaneously. That is the first plus point about version control system. It does not allow overwriting each other's changes. So as I mentioned, if there is a mistake made by the developer, a developer can turn back the clock and compare earlier versions of the code to help fix the mistake while minimizing disruption to all team members. Next is it maintains a history of every version. So as I mentioned, it has a special database which keeps track of all the modification of the code in special versions. For example, if X, Y, Z are the three developers, they have their code committed for say 2:30 p.m. So all these versions will be maintained, like X version 1 at 2:30 p.m. whatever the changes are made with in which set of lines and what files are modified. So these history are maintained in the special database. For all software projects, the source code are like crown jewels. So a precious asset whose values must be protected is nothing but done with the help of version control system. Like you can say for the software teams, the source code is a repository of the invaluable knowledge and understanding about the problem domain that developers have collected and refined through careful effort. So software developers working in teams continually writing a source code, like I mentioned in an example, like there are 50 members and they have continuous access to a particular source code. The code for the project, app or the software development is typically organized in this version control system. It helps you to track each and every individual change by their contributor and help preventing any kind of the conflicts. For example, if X and Y are the developers working on the file, say index.html. So version control system will help both these developers to understand which developer is working on which set of code in the particular file to avoid any kind of the conflicts. So that's all about understanding the basic thing about what is version control system. The next chapter will understand about the types and the different type of the terminologies which are used in the version control system. Hello friends, let's start off with understanding the version control terminologies. We saw about a brief description of what is version control system all about and the different type of the advantages of it. So these are the basic terminologies of version control. First one is repository, second is trunk, then comes tags, branches, working copy and commit changes. So let's understand each one of repository. What is repository all about? Repository is the heart of any version control system. It is like you can say a main place or a central place where developers store all their work. Repository not only stores files but also the history, like who has modified which changes and many more. Repository is accessed over a network acting as a server and the version control tool acting as a client. Client can connect to the repository and then they can store, retrieve their changes to and from the repository and so on. By storing the changes, a client can make these changes available to the people like other people, and retrieving the changes, a client can take over and he can make the people changes as the working copy. So all whatever the changes we do it is completely done in this repository. Next comes trunk. What is trunk all about? Trunk is a directory where all the main development happens and is usually checked out by the developers to work on the project. So trunk is nothing but, like, you can say a kind of a folder structure which gives you like which folder is accessible to whom. Next comes tags. The tags directory is used to store the named snapshots of the projects. A tag operation allows to give a brief descriptive and memorable names to the specific version of the code. Next is branches. Branching operation is used to create another line of development. It's like a tree structure, you can say. It has a main branch and the sub branch and sub branches and so on. So branch operation is nothing but creating like another line of development. Why it is useful? It is useful when you want your development process to fork off as like forking as different type of the branches. So fork off into two different directions. For example, when you release version 5.0, you might want to create a branch so that a development 6.0 happens. So this helps in branching system. This also does like the bug fixes for the previous version like 5.0 and 6.0 are maintained separately. Working copy. Commonly used term for the version control system. Like we are using the working copy for it. Working copy is a snapshot of the repository. The repository is shared by the teams, but the people do not modify it directly. Instead, each developer checks out the working copy. The working copy is a private place where developers can do their remaining work isolated from the team. So it is like a local copy for each and every developer. Commit changes. Committing. What is commit? Commit is nothing but a process for storing changes from private workplace to central server. After commit, changes are made available to the team members, all the team members who are there in the project. Other developers can retrieve these changes by updating their working copy. Commit is nothing but an atomic operation. Like it is either given or it is not done. It's 0 or 1, you can say. It's an atomic operation. Either the whole commit succeeds or it is rolled back. Users never see any kind of half commit, like it has done halfly and still pending. It never takes place in this. So this is about the terminologies. Next is understanding about the different type of the version control system. Basically, there are two types as I have mentioned in this slide. Centralized version control system, which is called as CVCS, and second one is distributed or decentralized version control system, that is DVCS. What is centralized version control system? Centralized version control system is a software that helps software developers to work together, and it has a central repository. So that is the first plus point. So let's understand each one of them. Centralized version control systems are based on the idea that there is a single one major master copy, you can say, or a central copy of your project somewhere, probably on a server, and the programmers will commit their changes to the central copy. It is like one main person is there and like one main folder, and all the developers do their changes and put it inside this folder. That is about the centralized version control system. It uses a central server to store all files, enables team collaboration, but there is a major drawback in it. What is that? It is like a single point of failure. The failure of the central server leads to failure of the entire version control system. Because whatever we are doing it is there in the central copy of your project. And that is like a worst scenario which will happen. But even in the worst case, if the disk of the central failure gets corrupted and the proper backup has not been taken, then it will lose the entire history of the project. So it's a major drawback. So now then comes to the picture of distributed or the decentralized version control system. They are designed with the intent that one repository is good as any other, and that merges from one repository to another and are just another form of communication. The distributed version control system not only check the latest snapshot of the directory, but they also fully mirror the repository. If the server goes down in some scenario, like I mentioned for the centralized version control system, then the repository from the any other client can be copied back to the server to restore it. Every checkout is a full backup of the repository. Git does not rely on the central server, so that's the major purpose of these version control system. Even if the major central copy gets corrupted or something, you have your own working copy. It's like you have a root, you have a number of branches in it. So that is about the distributed version control system. You can make changes, commit changes, create branches, view logs, and perform other operations when you are offline. You require a network connection only and only to publish your changes, that's to commit your changes on the major branch and take the latest changes. That is the major thing about the distributed or the decentralized version control system. So that's all about understanding the terminologies and the different types of the version control system. Svn Life Cycle. Before understanding the life cycle or something, what is Svn all about, I would like to tell you. It is nothing but the Apache subversion abbreviated as Svn, and it is this under the category of centralized version control system. And this is mainly to focus about understanding the centralized version control system, and later we can get into Git, which is a part of the distributed version control system. So for understanding Git, it is important to understand about the centralized work structure, and then we can move on to the different functionalities of Git in the further chapters. So understanding the life cycle of the version control system, first is for SVN, first comes with create repository. First, I'll explain you in brief, and later I will show you what softwares are installed and how the exact repository is being created. So first of all, the repository is created, and this repository is a central place where all developers store all their work. Repository not only stores files but also the history of the changes, as I mentioned in the previous chapters. And it maintains everything, whatever the modifications it has been done. The create operation is used to create a new repository. Most of the time, this operation is done only once. Repository is created only once and the code is manipulated as and when needed. So your version control system will expect you to say to identify it, like you need to identify whenever you create a new repository, such as where you want to be created, what should be the name of the repository, and many more things. So that is done with the SVN. Second comes is checkout. Checkout operation is used to create a working copy from the repository. Working copy is nothing but a private place. It's like a local copy for each and every developers. And later on, submit these changes to the repository. Next is update. Update, as the name suggests, is used to update the working copy. The operation synchronizes the working copy with the repository, as repository is shared by all teams, developers, and can commit their changes and working copy becomes older. For example, let's say A and B are the two developers on working on the project. Both check out the latest version of the repository and start working. At this point, the working copies are completely synchronized with the repository. Suppose B completes its work and efficiently and commits its changes to the repository. In that case, the working copy with A, that is previous developer, is out of date because B has committed the changes and the working repository, the main repository, has the updated changes. So the update operation will pull whatever B's changes are done, and that will give the updated copy to the A's version. That is how it works. Then comes with perform changes. After the checkout, one can do various kind of changes. Edit is the most common operation. One can edit the existing file to add, remove, and do the necessary changes in the file. One can add files directly, but immediately these files directories do not become a part of the repository. Instead, they are added to the pending change list and become a part of the repository after the commit operation. Similarly, one can delete files and directories. Delete operation immediately deletes file from the working copy, but actual deletion of the file is added to the pending change list, and the changes are made to the repository after the commit operation. So that thing I will explain you in detail. Once I explain these particular terminologies, I will explain a live example and tell you. Review changes is the next step. Review changes is like when you check the working copy or update the working copy, then your working copy is completely synchronized. That's all I can say with the repository. But as you do the changes to the working copy, it becomes newer than the repository. And it is a good practice to review your changes before committing the operation. So that is like a major operation of reviewing the changes. Status operation lists the modification. There is a status operation in SVN which lists all the modifications. But as we have mentioned before during our discussions, that whenever you make changes in the working copy, all these changes become part of a pending change list. And the status operation is used to see the pending change list. That is about the review changes. Another important thing, one can use the difference of operation to see different type of modifications that can be done. Fix mistakes is the next step. Let us suppose one has made some changes in the working copies, but now he wants to throw away these changes. He does not want to make any of the changes in that particular file, whatever he did for now. So in this situation, it is better to revert your operation, that is revert. Revert operation reverts. It's like it removes, undoes whatever the modifications that has been made to the working copy, and it is impossible to revert one or more file directories. So it's like possible also, but it is also possible to revert the whole working copy. So in this case, the revert operation will destroy whatever the pending changes has been done and bring back the working copy to its original state. That's about like fix mistakes. Resolve conflicts. Major part of the concern with the SVN life cycle, conflicts can occur at the time of merging. Whenever you merge a code of say developer A and developer B, then merge operation automatically handles everything that can be done safely. Everything else is considered as a conflict. For example, hello.c has modified in a branch and deleted in another branch. In such a situation requires a person to make a decision. The resolve operation is used for by the user to figure out the changes what has been. The next step is about committing. Once you have resolved the conflicts, so like I said, developer A and developer B has two different type of the versions and you want to fix both of them. So that is like merging happens with the resolve conflicts. Next is commit changes. Commit changes is like you are committing whatever you have completed. Commit operation is used to apply changes from the working copy to the repository. The repository modifies whatever the operations has been done and the developers can make the changes and commit it. Once committed, you cannot take it back. So before commit, one has to add the files directories to the pending change list and later he or she will commit the operation. So commit is an atomic operation, again I'm repeating, which means that either commit succeeds or it is rollback. User will never see any kind of half finished commit. So that's about understanding the life cycle. Next chapter, I will focus on the installation of Tortoise SVN and how a sample repository takes place, like creation with the performance, review changes, update, commit, and many more. After getting a better picture of SVN lifecycle, we'll move more on Git because understanding the centralized version control system is a must before you understand the other type of the version control system. So that's all for this chapter. So as we saw in the previous chapter of how the different stages and the life cycle of the SVN repository, that is a centralized version control system repository, works. This website is Tortoise SVN is a software which works on the similar functionality, and there is downloads also like for 32-bit OS and for 64-bit OS. As my operating system, that is Windows, my system is of 64-bit, I have downloaded this version and I've already done this. So after downloading, like it asks for the downloads thing, after downloading that particular version, you just need to run, because it's just a similar software like any other software, you just need to run it and execute it on your system. So for now, I'm not downloading it because I've already downloaded it. Now I'll show you like how in the particular drive, the repository for Tortoise SVN, that is SVN Centralized Version Control System, takes place. So if you remember in our previous slide, I have mentioned like first thing is to create a repository and second is a checkout process. So let's go to our drive. I have a drive, C drive over here. I'll create a folder. Folder name will be SVN. Okay. Later, I'll do a right click. In right click, you can see there are some options over here. SVN checkout, Tortoise SVN, and many more. So Tortoise SVN, I'll say create repository here. Once I click on this particular option, it gives me the thing that repository was successfully created. Do you want to create a default structure? The default structure is trunk, branches, tags, and many more. And the path is C drive SVN. So I say create folder structure. So it says that okay, the directory structure has been successfully created. Okay. Now I'll just go inside this particular drive of SVN. And you can see there is a folder structure. That is, there is a conf, there are db folder, there is a hooks folder, and many more logs and all that. After this I'll do svn checkout. So I'll just do a checkout over here. That was the first procedure, if you remember. So I'll just check out. So all the branches, tags, trunks, all these has been done perfectly. Now if you go to the C drive, I can see there is a tick mark and svnwc folder created. So it has a branches, it has tags, and it has trunks in it. So this is the way SVN actually works. The basic folder structure is present over here. So my first procedure is being done. Now what I'll do, inside branches, I'll create a sample file, a new file named demo.txt. For now, this file is not added to the system, it's just present locally. So I'll keep it locally. Now inside this file, I'll create, this is demo text file for SVN. Okay, I'll save it. I'll save this copy. Now what I'll do, first of all, I will add this file. So inside tortoise SVN, I'll say add. So this is the way a new file is being added. Then later, I will move inside this particular thing of tortoise SVN. After adding, I'll say commit. So inside commit, I will say there is a new file added inside the branch folder. Okay, the file is added, committing the transaction has done. Okay, now again after here, you'll again see a tick mark after refreshing. This means the commit has been done. Suppose now I make again some changes over here. I open this file and just mention some author name. Some changes have been done. I make a change and that's it. Save the file. You'll see a red mark over here. What does this red mark actually indicate? The red mark indicates that there are some changes made in the file, but it has not been committed yet. So simple. Right click and I'll say commit. And I put a message over here. First and important primary thing which I need to mention, it's a very good practice to always give a message over here, because whenever someone maintains a history and he gets the message changes, then it helps, it makes him very simpler to get the information. Okay, changes done. Now again you'll see there is a tick mark, which means you have an updated file with you. You can also do an update over here to see that if some other user has been made a changes, then it has been updated or not. Once it is done, it says completed at revision 3. So it gives a revision number for each and every update, commit, and any changes done. So this was about the major structure of SVN, the life cycle, as I mentioned in my presentation. Like first of all, I made a repository, I made checkout and then updated it, performed some changes, how to review changes and see. So that we'll see for now. I'll go inside my directory and I'll click on tortoise SVN, and there are n number of options, if you can see, like check for modification, revision graph, show log. Show log will help you to understand like who has used this particular file. Before the beginning of the chapter, I did mention that there is a special kind of a database which keeps a track of who is a user and who has done everything. So here the username is there with the time and with the message, like what changes has been made in the particular folder or file. So file name was nothing but branches demo.txt, and these all changes has been done. So this is a way of analyzing the statistics of the SVN. So if conflict, whenever what happens in conflict? Suppose this file is modified by me and some other user, then both of them try to commit it. Suppose I committed and later the user committed with the old version of the copy. Well, in that case, he gets a conflict and the conflict message is displayed in SVN. With the right click, you will get a conflict also. And later, the merge option helps you to merge whatever the changes has been done. The updated changes is maintained in record. So this was about understanding, like a demo example of how SVN, that is a basic example of a centralized version control system, takes place. Now you have got a better picture of centralized version control system. Later we'll move on to, in the next chapter we'll move on the distributed version control system, that is Git, and how it works. So we'll check out of the basics on the next chapter. After having an overlook of the centralized version control system, we'll have a look about distributed version control system. That is nothing but a best example to know is Git. Distributed version control system not only check out the latest snapshot of the directory, but they also fully mirror the repository. If the server goes down, then the repository from any client can be copied back to the server and restored it. Every checkout is full backup of the repository. Git does not rely on the central server, and that is why you can perform many operations when you are offline. You can commit changes, create changes, view logs, and perform other operations when you are offline. You can require network connection only to publish your changes. That's the only thing, that you will require network connections if you need to publish it. Let's understand the working of the Git. So the working directory, staging area, or you can see the index. The working directory is the place where the files are checked out, and in centralized version control system, like we saw in the previous chapter for SVN, developers make modifications and they commit directly to their repository. But Git uses a different kind of a strategy. Git doesn't track each and every modified file. When you commit an operation, Git looks for the files present in the staging area, that is the next area which you work on. These files present in the staging area are considered to be commit and not all the modified files. For example, you have modified file A and file B. It will not keep a track of each and every file. When you say commit, then it takes the overall staging area, that is your file A and file B, and then it is to be committed in the Git repository. So first is you can modify a file from the working directory. You can add the files in the staging area. You can perform commit operation that moves the files from the staging area, and after the push operation, it stores the changes permanently in the Git repository. So that is the major thing about Git. Next is about branches. Whatever we are doing over here is maintained in the branching system. That's why it is called as the distributed version control system. Branches are actually used to create another line of development. By default, Git has a master branch which is same as a trunk in the subversion. Usually a branch is created to create a new feature. Once the feature is completed, it is merged back to the master branch, and when we delete the branch, so every branch is referenced by the head which points to the last commit in the branch. Whenever you make a commit, head is updated as the last commit. So that we'll see once we check out for the environmental setup. So next in this chapter continuation, I'll show you how Git is installed. And before that, we should understand the online repositories for the Git. Two major sources are there. One is Bitbucket, second is GitHub. Bitbucket is an Atlassian project, and GitHub is also a place where the online repositories of Git can be stored. So the next thing which I need to focus and mention you about how Git has been installed and how the repository has been cloned and maintained in the system. So let's go to our browser. So this is a download structure for whatever important downloading aspects for Git. It has support with the Mac OS system, Windows, Linux, and Solaris. So we have all these systems over here. I have already downloaded the Windows system so that I'll show you the bash thing over here. I've already downloaded the software. So Git GUI is also there, and a bash scripting, like the command shell, is also there. The best thing is to create with the help of bash thing, create new repository. So it is ask for the directory. Suppose I go on for C drive and I say some folder. I'll create a folder first of all, a new folder, and the folder name is Git. Okay, so I have already created a repository. Now if there is something to be cloned and if there is something to be opened, so all these structure is present over here. So this is a GUI thing, but I'm mostly focusing on the command structure, that is nothing but with the help of the bash thing of Git, so which I'll tell you. So the git bash command, this helps you like the command structure. It is just like the Linux structure, which gives you the complete list. This it also gives you to the directory thing, like which one I want to switch it. So cd C drive. So I have switched to the C drive. If I say the ls, I get the list of the files. So that's how it actually works. We have vamp, blue is for the folders. So we have a git over here. So I'll move to git structure. Point to be noted, it is similar, absolutely similar like any other Linux thing. So Linux command terminal. So I have pointed to the git. If I want to reinitialize the repository over here, so I'll say git init. So I have initialized empty git repository with the master branch in it. Next focus is about how we need to clone it. So cloning the thing is done with the help of an online repository thing. How the online repository thing works is a simple thing, like it's done with the help of GitHub or Bitbucket. So I'll go to bitbucket.org. Over here, I've already created a repository. I have an account over here, so which is present over here. If you don't have an account, you need to create an account and make it. So I have a repository, name file upload. Now inside this file upload repository, I'm going to make a clone of it. So I'll click on this repository and it gives me a path of how Git cloning is actually done. Cloning is nothing but copying the particular program structure or the application structure in your system. So this is my online repository. If I click on clone over here, it gives me the complete command, git clone and the path name. So I'm just going to do a simple thing, is nothing but copying this path and will move to my command prompt. That is my bash command prompt of Git and paste it. That's all, and just click on enter. So this will nothing help me to clone a particular file name. So I'm just waiting for that. Okay, it asks me for the credentials. So the username and the password. Username is Radzimkar, which I'm going to give over here, and the password is here. If it will authenticate properly, it will do it. If the authentication is failed, then it will give me the error. Again, I'll do a clone and enter the appropriate password and try it out. Let's check it out. I guess if I have forgotten the password, or else I'll reset the password and again try it over here. It does not take so much time. If the authentication fails, it gives the appropriate message. It always takes for the username and the password for cloning the particular repository. It will take a while. Yeah, the authentication has been failed. So best thing is nothing but to go to a browser and change the password thing. So I'm going to manage it, or in the simple way, I'll just log out from here and change the password. Whatever the username and the password, I have it over here. The same username and the password should be given to the while cloning a particular structure. So yeah, I've made the changes in the password. Now I'll again do the cloning structure over here, paste, cloning to file upload. Then again ask me for the username and the password. It always takes a while because it's a kind of a slow process of authenticating with a given username and the password. Or better, we try to terminate it and do it again. Yeah. fatal destination file upload already exists. So I guess it has already created the folder. Okay, just do an ls. Okay, just go to our drive. Now inside the drive I have a git folder. I'll just delete this particular thing. Again I'll do the authentication cloning into it. It always takes a while because it's kind of a slow process, because it's creating a complete copy of whatever it is present in bitbucket.org. So let's wait for a while. Okay, there is some internet issues, or else it definitely happens. Okay, yeah, it has cloned appropriately. So let's go to our folder. Yes, it's done. So we have an empty folder of file upload. Obviously there was nothing existed in it. So we have created a cloning. So whatever folder was present in my bitbucket.org, it has been created over here. So this was a step of cloning a particular repository of Git in your system. So in the next chapter, we'll understand the complete life cycle of Git, like how Git exactly works and how it is different in compared to the SVN structure. Understanding the life cycle of Git is very important before we start on creating a new repository and making the necessary changes. So we have a repository over here. So general workflow we'll understand over here in this chapter. We have a repository. The repository was nothing but the clone repository if you have seen in our previous chapter. So we have a main repository in the Bitbucket. We had it. We cloned that, and that was created as a working copy. If you remember, the working copy is nothing but the local copy of the user. If a user wants to modify, add, edit, or delete any kind of the files in it. So this modifying working copy is done with the user. He can edit, add, move files. The update operation takes place with respect to this modify working copy. So if necessary, you can also update the working copy by taking the other developer changes that takes place over here. In this way, the distributed version control system makes it handle. And the next is you can review the changes before you want to make any kind of commit. So status and difference operation helps you to make a review of the changes. If there is something which you want to say that I want to make a change over here, or there is some issues over here, so that complete review of each and every step is taken place. After you are sure about it, like yes, I'm done with the changes, now I'm ready for a commit or a push operation. So you can commit changes if everything else is fine. Then you push the changes to the repository. So it's done to the repository. Another point to be noted over here, this is your own branch. There is nothing related to the concept of centralized repository system. So it's completely your own. You can make n number of changes what you want to do it over here. So you can do it, you can push the necessary changes, and after committing the changes, it may happen you realize that something has gone wrong, then you correct it, like you kind of fix the mistakes over here, and again you do a push operation. So that push operation is also done in this repository. So the entire life cycle or the pictorial representation is here. I'll repeat again. You can clone the Git repository as a working copy. You can modify the working copy by editing or deleting the files. If necessary, you can also update the working copy by taking other changes, and that update operation takes place. And you can review the changes before commit with the help of status and difference operations. And after that, you can commit changes. If you feel like everything is fine, you can commit the changes, and you can push the changes to the repository. It may happen sometimes like after committing, if you realize something is wrong, then you correct the last commit and push the changes again to the repository. So this is all about understanding the life cycle of the Git. In the next chapter, we'll focus on creating a file, creating a new folder or something, and then uploading it, like you can say committing it the changes with the help of the push operations and many more. So that's all we will understand, like operations in Git, in the next chapter.